Hi, I'm going to give you a quick introduction to Bisonkick. Bisonkick is a physics game level editor. It allows you to quickly design your Box 2D or NAPE or any type of physics game and export the data anywhere without having to really write much code at all or zero code. And the support for all of those different types of games will be coming as time goes on. So the way you use Bisonkick is you go to bisonkick.com. If you sign up for a free account, you'll get unlimited public designs, which means that all of the designs you make are available to anyone who wants to play them. If you sign up for a cheap free account, then you can save your designs privately, and all of them are saved on the cloud. But you can also get your designs exported, and you don't need to save them at all on the cloud. But if you want to reopen them and design them in Bisonkick, then right now you do need to save them here. So if you just go ahead and click Start, or in this case, let's load an existing public design. This one's called Conveyor. Conveyor kind of gives a good example of all the different things. So you notice that you see a lot of blue and green. The green means that an object is static, and the blue means that an object is dynamic. If we play this, you can see that the static objects are fixed in space and the dynamic objects move. The way that you play an example is by pressing this green arrow button at the top, and you can also use spacebar. Now you can see that these balls are moving. That's because they have joints attached to them. You can see all the different joints, which are lines, and you can even see some lines that aren't connected to anything. So I'm going to give you an idea of what those are in a second. The first tab is the selected tab. That refers to the shapes that are on the screen. And the second tab is the joint tab, and that refers to the joints that you're currently selecting. Now the way that you select a joint is you select a shape that has the joint, and it'll show you all the joints that are attached to that shape, and it'll highlight the one that it's referring to in orange. So if you want to highlight the other joint that's attached to that shape, you click here. So of course, if you were to highlight all of these, you can use that lasso rectangle and drag all around that. You can see all of the different joints that are attached to all those different shapes, and you can change the properties of all of them one at a time, and you can see them getting highlighted here. Now what are these black lines? Those are joints also, but we needed a way to represent joints that are attached to space, meaning joints that are attached to the outside world. They're not necessarily attached to a body. And so that's what those black lines are. To create a joint, you click this button up here, which is the joint button, and it puts a kind of blue haze on it, and when you mouse over something, you can see a little golf ball appear. You can drag that, and until it turns green, once you let go, then you're good to go. And you can do as many of those as you want, and you can just click done when you're finished, and there's a joint. So if we examine this joint, here's a distance joint, and by default it's a distance joint. You can change all the different properties. You can change the joint itself to be, let's say, a motor joint, which is what these are down here. And if you want to delete that joint, you just click this disconnect button, and that deletes the joint. And of course, if you delete the shape, it will delete the joint. So what I did here is I attached a joint to every single one of these squares up here to create kind of a conveyor belt. And each one of the joints is a distance joint. Now a distance joint has a minimum and maximum width that it'll kind of stick to. So each one of these joints is 30 max and 30 min, which means that they'll always be 30 pixels apart no matter what. And around them we have two circles here, and there's a pinned joint, but it's rather difficult to make. It takes a little bit, so I made a shortcut here called pinned. So if you just want to pin anything to the stage, you just select this pin button. And also you can see there's a camera button there. So if we click camera follow here, you'll see it puts a little star on the one thing that's going to be followed by the camera. If we press play, you can see that the camera is actually following just that ball as it gets tossed around. And only one thing can be followed by the camera. If we click pinned, you'll see what happens to that one. It's pinned up there, but it's rotating around that pin. Now, if Now each one of these shapes can be edited over here in the shape section. So if you select this shape, then you can click here and it will highlight that area and you can change the shape. Currently, if you are going to press enter, you can also edit these properties down here, which technically belong to the body as a whole. But right now we don't have groupings, so they kind of belong to each individual shape. Each one of these properties you can look up. They're pretty available. For example, angular velocity is how much initial spin. It's kind of the spin on the object. So if I set a high angular velocity, and you kind of have to play with these numbers to see what number is going to be right. If I add 60, let's add 100 to that one, you'll see that just that shape right there, well, you can't really see it because it gets covered quickly by other shapes, but it has an initial spin. If we were to add a big enough spin, and we can disconnect that property by clicking here. Okay. Now, these shapes have this joint to space. So that's a motor joint, and you can see that it's between this and that UG1. That's just a random name that it gave it. We could call it, let's call it motor 1. And it's helpful to give these things names. And we'll call this one, instead of UGL5, we'll call it motor 2. So now if we look at the joints, we can see it's between motor 2 and space, and this one's between motor 1 and space up there. And here's the max force. That's how much kind of power the motor has. And each one of these joints has different properties. And here's a ratio, and here's the rate. The rate is how fast the motor moves. So if we change this one to 20, and it also helps if we change this one also to 20, and we press play, you can see that the motor moves a lot faster, and then it just starts to really launch those balls. Now, one other thing to note is that I have this box right here, keyboard controlled. So if I press play, you can see that I can move that box around with the keyboard. Now, how did I do that? Again, any joints that you want to select, you have to select the object itself. So when you click events, any events that you want to see, you select the object itself. So what did I do? I can click this plus button to add an event. I have two events here, and they're both on this pusher shape. So you can see that the name of that shape, if I go back here, says pusher. And so pusher has a key down event, so we can select it right now. We'll do key down, and you need to give the key code of that key. You can click here to see all the different key codes. So we wanted the right arrow. So the right arrow is 39. So in here we enter 39. And what do we want it to do when 39 gets clicked? We have a couple of different choices here. What we want is an impulse. An angular impulse, again, that would be a spin, but what we want is an impulse. And what you do for the impulse is you enter two numbers, and it gives you instructions down here. We'll delete this other event for right now. Two numbers, the X and the Y. So we actually wanted to move along the X, and 39, that was to the right. So let's say we give it 200, and for the Y we'll give 0, because it's not going up or down. And when we click play, you can see that it does have a little bit of impulse there. Maybe we need a little bit more. And if I press left, it's not going anywhere because that event is not hooked up yet. So let's add, first of all, let's make this more like 700 to make it move a little more. Let's click play. That makes it move a lot more. But we still can't go left, and now we're just jamming up that conveyor. So let's add one more event for the right button, and we still have that shape selected, so it's the only choice under here. We click when what. So when the key goes down, and which key is it? Let's check here. We want the left arrow, which is 37. So we enter 37 here. And then what happens when we click 37? We want an impulse again. And now instead of 700, 0, we want it to go negative 700. So it'll go the opposite direction and 0 along the X coordinate. So now if we click play, we can see that I have both directions working. Okay, so that's good. Now what if we want it to fly? What if we want it to go up? So that's going to be the y coordinate. So let's press plus again. And when we look at our drop down here, we only have one choice because we only have one shape selected. We click pusher. We want key down, and we need to know what the up arrow is. So that's 38. If we look in that box, we click close. 38. And what do we want to happen when they click 38? We want another impulse. And this time on the X, it's going to be 0. And on the Y, for it to go up, you want a negative number. So let's do negative 700. So that's 0 on the X and negative 700 on the Y. We click play. So we have our right, we have our left, and we have our up. So now that, and we can actually kind of float there. Okay, so that's good. And one more we probably want to add is just a down. So when shape pusher, key down, and we need to know the key code for the down arrow is 40. So 40. So if I was logged in, I'd be able to save this. Right now I actually can't save this because it's not my design. I don't own this design, and I'm not logged in. So we won't be able to save this right now. That's why you got to log in. But we will be able to export it. And we click impulse. So the key down, when the key down gets clicked, X is going to be 0 and Y is going to be 700. Now that's going to really shoot it down. Maybe we should just do 200 to kind of lightly, because there's already gravity on it, so we don't need to further do that. We click play. We have our up, and our down goes down pretty quick. And we have left and right. So now we have a fully controllable object here. Cool. And what we could even do now, just to give you an example of joints, is we could take this circle here, and let's take the joint tool and attach a joint to it. And we'll just do a plain distance joint. So if we go to joints and we select this object, we can see this is a distance joint. The minimum is 150 and the max is 250, but you can see the length between the two, which it says right here, is 81. So maybe we want to keep the length at 81. Okay, that's good. And a lot of these, if you enter the wrong numbers, you can really get some very strange results. And I'm not going to stop you from getting strange results, but it's not a bug if you do. Just like in the events, if you try and remove an object that's not there, an error will pop up. It's not going to crash the program, but it will show you an alert. So now we have this guy attached to this guy. So now we can actually drag this guy around with us as we fly around. So that's pretty cool. And maybe we just want to slow down this motor again. And you can, let's say we wanted to have more balls up here. There's a bunch of shortcuts that are available. D is for duplicate. There's no copy and paste, but there is D. So if we click D, we can duplicate all of these shapes at once. So now there'll be a lot more coming down from there. And let's slow down these motors. So if we click here, we can see that that motor is between the motor 1 ball and space. So right now the rate is 20. Let's change it back to 2. And we probably should do the other one the same. We click on that. We see the rate is 20. Let's change it back to 2. Now we have a lot more balls coming through there. We have our guy. And he can fly. So you get a lot of features without really writing any code at all. And as the last thing I'll show you, you can click this button up here, which is to export your design. And you can export it in a number of different ways. This gives you JSON code, JSON, which you can pretty much use in any coding environment. So that's kind of the one that you could use anywhere. And I have, at the moment, 3 other ones. You have ActionScript, and this is an entire class that's written. It's not exactly perfectly indented and everything, but it does work perfectly. So if you were to just click there and highlight that, you have an entire class written. And I have a helper class that you don't need to write any code to implement this. All you need to do is include the other two classes, and this will just work. I also have a JavaScript sort of class here called levels. It's very similar to the ActionScript one. And if you were to take this whole thing and copy it, and we were to, say, open up developer tools here in Chrome, you can see in the console, if we were to just enter that in and press enter, now we have this thing called levels. And if you were to expand that, you could see that it contains a level 1 object, and in that it contains events, an array of events, an array of joints, an array of shapes. So here's all the shapes. There's 111 shapes in this case. So here's 0 to 90, and in each shape you can see it contains the body type, which is static or dynamic, H for height, a name ID, which we either let it name it itself, or we named it ourselves, and the type is going to be square, circle, or polygon. And in this version of Bisonkick, you can actually use convex polygons and polygons that are in any direction, clockwise or counterclockwise. And you see you have a width and a height and a unique ID. So the name ID is not necessarily unique. You can name different shapes the same name, but the unique ID will always be unique. And you have the rotation, which is in degrees, and then you have the Y. Now, you also have this props object, which in some cases, if you gave the shape an angular velocity or something like that, then in that case you would have other properties in there. So here's all those. And you also have the events. So let's see if we go back. So this will show you a list of the events that you added. So we have, now this is just a very generic way of defining all types of events. So what is going to be the type of event itself? So it's a key down so that you can kind of form a sentence with this. Who is going to be the unique ID of the shape that it's referring to. Who extra is going to be if that shape has any special properties, like if you defined an alert or something like that, what is the message of the alert? Well, no, that's for then. And what extra, so what key did you want to press down? So that's what extra. And in who, the case is like if you have a collision, well, who are you colliding with? So that's the who extra. Then here's the then extra. So this is an impulse, and the extra information about that is this impulse is 700 and 0. And then you also have, lastly, you have the joints. And these are defined the same way in ActionScript and in the obective-c arrays or NS dictionary. The joint type, which is going to be distance, motor, or weld, model 1, model 2. And at this time, we only have sides as center, so where the joint is attached. But in the future, there will be more, so we still have that available. And the unique ID of the joint itself. So, and then if the joint has different properties, like break under force, where if you give the joint enough force, it will completely break apart and disconnect and stuff like that. So that's just a quick tutorial on Bisonkick. I hope that helps.